Hello everyone and welcome back to Math 127 Pre-Calculus 2. So in this lesson, we will be covering now the section 5.4, which is the product to sum and the sum to product formulas. But before we begin, let's quickly connect today's lesson to what we have already learned in this chapter. So far in chapter 5, we've worked with sum and difference identities. We already went over with double angle formulas, the power reducing formulas, and half angle formulas, and of course, the fundamental identities. So each of those identities allowed us to rewrite trigonometric expression into different but equivalent forms. So for today's lesson, we will continue that same idea. So this time, we are going to learn how to convert those products of trigonometric function into sums or differences, and how to convert those sums and differences, and of course by vice versa, into products. So at first glance, these formulas may look intimidating because there are several of them. However, you'll notice that the process is actually very systematic. So once you identify the two angles involved, the rest becomes substitution and simplification. So by the end of this lesson, you should be able to use product to sum formulas and sum to product formulas to rewrite the trigonometric expressions and then evaluate exact value. Okay, so let's go ahead and begin with the product to sum formulas. Okay, so before that, let's take a look at our first set of identities. These are what we call the product to sum identities or formulas. Okay, so because we start with a product and then end up with a sum difference, so the main purpose of these formulas is to rewrite products involving sine and cosine into expressions that are often easier to simplify or evaluate. So notice each of these formulas involve two angles, the angle alpha and then the angle beta. So as we work through examples today, I strongly recommend identifying the angle beta and angle alpha and angle beta first before writing anything else. Okay, so doing that helps avoid most mistakes students make when applying this formula. Okay, so let's go ahead and start with our first example. Okay, so express the product as a sum or difference. So given here we have the sine 5x times the sine 2x. So obviously here in this statement we do have product since the operation is a multiplication. So what I'm going to first identify the angle alpha here. So we see here that angle alpha. Let's just say this is our angle alpha, and then this is our angle beta. Okay, so in this case, I'm going to use the sine times, okay, sine alpha times sine beta. So you can see here from the list of the formula, I'm just going to go ahead and apply this formula. Okay, so now I will have, in this case, that 1/2. Okay, so 1/2 cosine, okay, alpha, which is the 5x, and then minus beta, which is 2x, and then minus cosine, and then alpha is 5x, and then plus beta, which is 2x. Okay, and then after that, we just need to simplify each of those angles. So we now have here 1/2, and then we get cosine, and then we have 3x minus cosine, we have 7x. All right. Okay, now I am now going to distribute the 2 to each of these terms. So now I will have to multiply. So that's going to be now 1/2 cosine 3x, and then minus 1/2 cosine 7x. Okay. All right. Now, as you can see, we now have here a difference of those two terms. Okay, so this is now expressed in a sum or difference. Okay, all right, now let's go ahead and work on with the next expression here. If you are now getting the steps here, I would advise that you can stop the video and then work on with letter B. Okay, so given here cosine 7x times cosine x. Okay, so I would say that once again, this 7x right here is equal to, okay, so sorry. So 7x here is our angle alpha, and then x here is our angle beta. So again, I will be applying the formula, which is again 7x and then x for the cosine. Okay, so as you can see here, we have cosine alpha, cosine beta. In that case, I will be applying this given statement. Okay, all right. So moving on to, we have the cosine. Okay, so we'll start with the 1/2, and then we have a cosine 7x minus x, and then we have plus cosine, and then 7x plus x. Okay, so as you can see, I just exactly copy the formula here. We're just replacing that angle alpha and angle beta. Okay, next we now simplifying those angles. So 7x minus x is 6x, and then plus cosine 8x. All right, and then now we will be distributing the 1/2 to each of this term. So that's gonna be 1/2 cosine 6x plus 1/2 cosine 8x. All right. Okay, so there you go. It is now written in the sum of two terms. Okay, so these are now our final statement. Okay. All right. So now that we have learned how to convert products into sum, let's look at the reverse process, okay? So instead of starting with a product, we will start with sum or difference, and then we write it as product. Okay. Okay, so we do have here these identities. Okay, so these identities here are called the sum to product formula. So think of them as the opposite of the formulas we just used. So instead of expanding expression, we're going to compress them. Okay. So these formulas are especially useful when evaluating exact values because they often create familiar angles from the special right triangle or the unit circle. So one thing I want you to notice is that all four formulas involve two common steps. Okay, so the first is to find the sum of the angles. Second is to find the difference of the angle. Okay, so to divide both results by 2, that pattern appears repeatedly throughout all four formulas. So let's go ahead and try the example here. All right. Okay, so given here we have the sine 7x plus sine 3x. So once again, I'm going to say that this 7x here, I will represent this as angle alpha, and then 3x here would be my angle beta. So, and then after that, I can see that I have a sum of two sine function. In that case, I will just go back so I can show you what formula I'm going to use. Okay, so in this case, I am using the first formula right here. And then once again, I'll just be following exactly this statement and then replacing that angle alpha and angle beta with 7x and 3x. Okay, let me go ahead and do that. So now I will have 2, okay, 2, oops, it doesn't work. Okay, so we have 2 sine 7x plus 3x alpha times the beta over 2. And then times cosine, we have 7x minus 3 over 2. Okay. All right, next we will just be simplifying the two inputs. So we do have here 7x plus 3x, we get 10x. And then divided by 2, we get 5x. And then cosine, oops, this is x. Okay, cosine, we have here 7x minus 3x. And then that gives us a 4x divided by 2. That's going to give us 2x. Okay, so this is now the product form of this given expression. Okay. Now let's go work on this statement once again. And like I mentioned earlier, please pause this video and then go ahead and work this out independently. And then after that, compare your answer with my answer here for the second statement. Okay. So for the cosine plus cosine, we see here a formula, okay, which is this statement right here. So I'm just going to go ahead and follow that. Okay, so remember, I'm just going to go ahead and say that this 3x would be my angle alpha and then this 2x would be my angle beta. So now following that formula, this is 2 cosine 3x alpha plus the beta 2x divided by 2. And then cosine, we have there alpha minus beta over 2. Okay, and then simplify. So now we have cosine. So we have here 2x plus 3x, sorry, 3x plus 2x divided by 2. So that's going to be 5x over 2. Okay, and then next factor, we have 3x minus 2x divided by 2. So that's going to be x over 2. Okay. Okay, so now we see here a statement which has an operation which is a multiplication. Okay. All right, so there you go. Okay, so moving on to the next example. All right. Okay. So for the next example, we are going to find the product of the exact value. For example, we have here the sine 345 degrees plus sine 105 degrees. So same thing, I am going to say that 345 degrees, I'll treat that as angle alpha, and then 105 degree is angle beta. So with this, I will be using the formula of the sum of sine function. So we have 2 sine 345 degrees, okay, and then plus 105 degrees over 2, and then cosine, we have 345 degrees minus 105 degrees divided by 2. Okay, and then we will be simplifying this now. So we have 345 plus 105. So that's going to be, okay, hold on. So that's going to be 345 plus 105. So we have 450. And then divided by 2, that's going to be 225 degrees. Okay. Next one, we have that cosine 345 minus 105. Okay. And then divided by 2, now we get there 120 degrees. Okay, and then after that we will now be simplifying this. Well, you all know that whenever we are simplifying this type of angle, what we're going to do is to find their reference angle. Okay, so first I'm just gonna go ahead and draw that, and then we see that angle 225 degrees. Okay, that would be in quadrant 3. Okay, this is 225 degrees. And again, to find the reference angle here, so that's going to be 225 degrees, we will subtract it from that straight angle 180 degrees, which gives us a 45 degrees. So therefore, this is a 45 degree angle. So if I'm going to draw a right triangle here, now I'm getting a 45 by 45 degree angle. And we know that these two sides right here measures radical 2. And since this is in quadrant 3. So therefore, this x right here is equal to negative radical 2. And then the y here is equal to also negative radical 2, given that the hypotenuse is 2. Okay, so now if we are to evaluate the sine 225 degrees, we can evaluate that through its reference angle, which is the 45 degree. Again, by definition, sine is opposite over hypotenuse. So this is opposite, is negative radical 2, divided by hypotenuse, which is 2. Okay, so let me replace that now. So now we have 2 times the negative radical 2 over 2. Okay, now we move on with the cosine 120 degrees. Okay, let me just draw that. Okay, so for the cosine 120 degrees, so that's going to be, again, initial side here. And we see that 120 degrees here would be in quadrant 2. Okay, 120 degrees. Okay, so now since this is in quadrant 2, okay, we're looking for the angle, the reference angle over here, okay, between the terminal side and then the nearest x-axis, of course. And then we can say that this would be the 180 degrees. We will subtract that 120 degrees so we can achieve this measurement right there. So this will be equal to 60 degrees. Okay, so this is now a right triangle that measures here 60 degrees, and this is 30 degrees. Okay, again, if the hypotenuse is 2, then therefore opposite to if the hypotenuse is 2, then opposite to 30 degrees would be equal to 1, and then opposite to 60 degrees would be radical 3. Okay, and so if that's the case, I will now be going back to evaluate the cosine 120 degrees through its reference angle 60 degrees. And we know by definition, cosine is adjacent over hypotenuse. So this is adjacent. Okay, so this is adjacent over hypotenuse. And then also remember that the x-axis here, let me just complete the information, correct information here. Since this is in quadrant 2, x here is equal to negative radical 3. And then again, 1 here, I'm sorry, that is not the x value, definitely not, because this is in vertical. So it is the x, which is equal to negative 1. And then we have here that y is equal to positive radical 2. Okay, since this is in quadrant 2, x is negative. Okay, so now, according to the definition of cosine, like I mentioned, cosine is adjacent over hypotenuse. And adjacent to 60 degrees is negative 1 over hypotenuse, which is 2. So therefore, this is now a negative 1 over 2. Okay, and then multiplying everything here, this is just like over 1, so I can just cancel that 2 out, okay, by dividing both numbers by 2. And so the answer, final answer, would now be, so we have here that negative times the negative sign, that would be positive, so that's going to be radical 2 over 2, positive. Okay, all right, that is letter A for number 2. Okay, so now let's go ahead and work on with letter B. But before that, let me go ahead and erase everything here. All right, so there you go. So I have deleted everything there from letter A answers. Okay, so we can now focus with letter B, which is our last example. So once again, if you are now getting comfortable with those process based on letter A, you can go ahead and work on with letter B. It's just that the same thing. It will just be the angle is just expressed in radian. Okay, so let me go ahead and begin. Applying the correct formula for this difference of two signs. Okay, so according to the formula, this is sine. Okay, this is sine. Oops, 2 sine, and then so this would be my angle alpha, this would be my angle beta. Okay, so if that's the case, then therefore this is pi over 12, and then minus 17 pi over 12 all over, we have here 2, and then we have here cosine, and then we have pi over 12 plus 17 pi over 12 all over 2. Okay, now I'll just be simplifying the fractions inside. Okay, so now we get here that 2 sine, we have pi over 12 minus 17 pi over 12, that's going to be negative 16 pi over 12 over 2. Okay, and then cosine, we have here 18. Okay, so 18 pi over 12 all over 2. Okay, to simplify it more, okay, so that's gonna be, I will be dividing both numbers by, because we know that this is over 1. Okay, this is over 1. So I can just divide both numerator by 2. So 16 will become 8, and then 2 will become 1. Okay, again, I divided both numerator by 2, and that's okay according to the concept of fraction. So same thing here. So this 18 will become 9, and then this 2 will become 1. Okay. All right. So next one, we now have to simplify it further, okay? So we still see that 8 and 12 can still be simplified by dividing both numbers by 4. So 8 will become 2, and then 12 will become 3. Okay, in this portion here, I'll be dividing both numbers by 3. So 9 will become 3, and then 12 will become 4. Okay, now just to clean this up, okay, with the um, simplified version. So this is 2 sine. We have here that negative 2 pi over 3. And then cosine, we have here that 3 pi over 4. Okay. All right. Now let's go ahead and evaluate each of these functions right here. You can apply the odd and even function here, or you can just simply rotate that angle sorry, not counterclockwise, but clockwise. Okay. Clockwise direction. Okay. So let me go ahead and start with the negative 2 pi over 3. In my case, I just want to, rotate it counterclockwise. So I'll be applying the odd and even function identity. We know that if the angle here is negative, if I'm going to make this a positive according to the odd function, because sine is an odd function, then the entire expression of the sine function will now become a negative sign. Okay, so this will now be a negative 2 sine 2 pi over 3, and then cosine 3 pi over 4. Okay, so now I'll begin graphing this. So 2 pi over 3. So, okay, so initial side here. Okay, so 2 pi over 3. So 1, 2. Okay, so this is now the angle for 2 pi over 3. Okay, which is 60 multiples of pi over 3, which is multiples of 60 degrees. Okay, so now let's go ahead and proceed with the reference angle. So reference angle would be here. Okay, so drawing that triangle here. Okay, so let me go ahead and subtract that 2 pi over 3 from 180 degrees, which is the pi. Okay, so pi is simply 3 pi over 3, or simply pi, right? So minus 2 pi over 3, which is equal to pi over 3. Okay, so as you can see here, this is pi over 3, and then opposite here, we know this is pi over 6. Okay, now if our hypotenuse is 2, therefore opposite to pi over 6 is 1, and opposite to pi over 3 would be equal to radical 3. Okay, so now if we are to evaluate the sine 2 pi over 3, so negative 2, okay, so sine 2 pi over 3, we know this is, hold on, let me just go ahead and write those signs just to complete my statement here. So x here is equal to negative 1. So y here is equal to positive 3. Okay, it is negative 1 for the x because it is in quadrant 2. Okay, so now I'll go back with sine 2 pi over 3 through its reference angle, which is the pi over 3 in this case. Okay, so opposite, all right, over the hypotenuse. Okay, so that's going to be radical 3. Oops. Okay, so that's going to be radical 3 over 2. Now, for the cosine of 3 pi over 4, okay, so let me go ahead and grab this first in the side. So now I'll have this initial side here. Multiples of pi over 4, so that's going to be 1, 2, 3, okay? Also in quadrant 4, so this is 3 pi over 4. So again, to find the reference angle, we will subtract 3 pi over 4 from pi, okay, which is the straight angle. Or I can say this is 4 pi over 4 minus the 3 pi over 4. So now this is now giving you the pi over 4. So as you can see here, the reference angle here is pi over 4. Okay? So now if you are going to draw this is like pi over 4. Now, if the hypotenuse is 2, then therefore these two sides measures radical 2. And then again, this x value here must be a negative. This y value is positive radical 2. Okay, so now if we are to evaluate cosine 3 pi over 4 by its reference angle pi over 4, this is adjacent over hypotenuse. So that's going to be adjacent is negative radical 2 over hypotenuse, which is 2. Okay, so now we have negative radical 2 over 2. Okay, so now we will just be multiplying everything. So we know this is over 1. So I can just cancel this out, the 2 and then the 2. So I can get just simply 1. And then, of course, negative times the negative, that would be positive. And then radical 3 times radical 2, that's going to be radical 6 over 2. Okay, so there you go. So this is now the exact value of this statement. All right. Okay. So again, now it's your turn to practice. I know I didn't have the checkpoint part here in this particular guided notes. However, please practice it using the homework exercises given to you. And then once again, when you are solving them, please ask yourself, am I starting with the product or sum? Which formula should I use? Did I correctly identify the alpha and then the angle beta? And then after that, definitely did I simplify the angles completely? So the best way to become comfortable with these identities is through repetition, and practice. Okay, so again, you can go ahead and work on with the homework exercises. Okay, other than that, congratulations for completing section 5.4. So again, today we have learned how to convert products into sums and differences, how to convert sums and differences into products, and how these identities can help us evaluate exact trigonometric values. So one of the major themes throughout the chapter 5 is that the trigonometric expression can often be rewritten in multiple equivalent ways. Okay, so the more identities you learn, the more tools you have available to simplify and solve problems efficiently. So before you move on with the next section, make sure you complete the homework exercises and then review today's examples. Okay, thank you for watching, and I'll see you in the next lesson.